Welcome to the another class of RCC structure. In this class, I am going to discuss about column, RCC column. Column is the vertical member of any structure. It is also called compression member because generally column takes the compression. Column is also very important member of any RCC structure because loads of any structure through slab go to the beam, after that column, and through column the total load go to the substructure. Before starting design of RCC column, in this lecture I will discuss about few terminologies of RCC column, few types of column, and analysis and design aids of RCC column. First of all, we have to know the most important term, that is slenderness ratio. The slenderness ratio of a column or compression member is defined as the ratio of effective length to the least lateral dimension. Now, what is effective length mentioned here? Effective length of a column is defined as that length of the column which takes part in buckling under the action of loads, or this is also defined as the length between the point of contraflexure of the buckled column. So, this is the most important term of column, slenderness ratio. Now, depending upon the slenderness ratio, the column is further classified in two parts. One is short column and another is long columns. The column is considered as short when the slenderness ratio of column, that is the ratio of effective length to least lateral dimension, is less than or equal to 12. Here L suffix EF denoting effective length of column and B is denoting least lateral dimension. In case of square or rectangular column, we have to use this B, the least lateral dimension, but in case of circular column we have to use D, that is diameter of that circle instead of least lateral dimension. Okay, and in any question or in any problem, length, effective length may not be given, but length may be given. If length is given, we have to find out effective length from table number 28 of IS 456 2000, and the effective length is depends upon the support condition of the column. Here in your screen you can see table number 28 of IS 456 2000. So, this is how, look at extreme left there are the support condition, after that the symbol of support condition, and there are the values. Some coefficient is multiplied with the length, and these are depends completely on the support condition. Okay. Now, next is long column. If the slenderness ratio of the column is greater than 12, then it is called as long or slender column. So, this is the basic two types of columns depending upon slenderness ratio. Now, the difference between the short column and long column is, as we read earlier, a column is considered to be short if the ratio of effective length to its least lateral dimension is less than or equal to 12. And in case of long column, a column is considered to be long if the ratio of effective length of column to its least lateral dimension is greater than 12. Number 2, the ratio of effective length of a short column to its least radius of gyration is less than or equal to 40. And for long column, the ratio of effective length of a long column to its least radius of gyration is greater than 40. In case of short column, buckling tendency is very low, and in case of long column, long and slender columns buckle easily. Now, number 4, for short column, the load carrying capacity is high as compared to long column of the same cross sectional area, and in case of long column, the load carrying capacity of a long column is less as compared to short column of same cross sectional area. Now, last, number 5, in case of short column, the failure of the short column is by crushing, and in case of long column, the column generally fails in buckling. Now, depending upon the lateral reinforcement, that means which reinforcement tie up the other main vertical reinforcement, just like stirrup of beam. This type of reinforcement is called lateral reinforcement. So, an RCC column has longitudinal and lateral reinforcement. So, they can also classify it according to the manner which the longitudinal steel is laterally supported or tied. So, there are two types: column with longitudinal steel and lateral ties, and column with longitudinal steel and spiral ties. Column may be further classified based on the type of loading. In figure A, this is axially loaded column, as you see. Now, what is axially loaded column? As you see in figure, the column which is subjected to loads acting along the longitudinal axis or centroid of the column section are called as axially loaded columns. Axially loaded column is subjected to direct compressive stress only, and no bending stress develops anywhere in the column section. Okay. Now, in the middle, figure B, eccentrically loaded column. Eccentrically loaded column are those columns in which the loads do not act on the longitudinal axis of the column. They are subjected to direct compressive stress and bending stress both. Eccentrically loaded column may be subjected to uniaxial bending, as you can see in figure B, and or biaxial bending, as you can see in figure C, depending upon the line of action of the load. As in figure B, you can see load is acting not on centroid but in any axis. But in figure C, you can see the load is acted not any axis, is anywhere of cross sectional area of column. So, in case of figure B, uniaxial bending comes, and in case of figure C, biaxial bending comes. That's all for this lecture. Thank you.